Hey girls, welcome to Calculus. So today we're starting Chapter 7, Integration, which as I told you last class is kind of the opposite of everything we've done in Calculus so far. All of our Calculus so far has been focused on derivatives. So Chapter 7, and specifically Section 7.1, is focused on antiderivatives. So to give you kind of a overview, calculus is basically broken into two main concepts: derivatives and integrals. So chapters 1 through 6 so far have been focused on taking derivatives and using those derivatives, such as slope of the tangent line, rate of change, related rates, differentials, etc. For the rest of the year, we're going to focus on the second calculus concept, integration. So integral calculus is chapter 7 and 8, and that involves functions such as finding the areas, lengths of paths, probability, calculating the location of an object when we know velocity and initial position, etc. So from here to the end of the year, we're going to be focusing on integral calculus rather than derivative calculus or differential calculus. So one way to talk about integration is anti-differentiation, again also called indefinite integration. The purpose of that is if you're given a function such as 5x to the fourth, if you're told that 5x to the fourth is the derivative of some function f of x, our goal with anti-differentiation is to find f of x. So we're trying to find the function, the original function, if we're given the derivative. So this is this box right here puts that into words from the book. So the definition of antiderivative is a function capital F of x for which the derivative of f of x, of capital F of x, is f of x. So we're trying to find, and that is said to be the antiderivative of f of x. So anyway, it's kind of complicated to talk about. Let's look at an example. So for example, if we were given that f of x equals 3x squared, and we want to find the antiderivative, capital F of x, we want to basically find what function, if I took the derivative, would be 3x squared. So think about that for a second. And actually, when you think about the derivative rules, hopefully you would come up with the fact that x to the third, if capital F of x equals x to the third, then f of x, the derivative of f of x would be 3x squared. So x to the third is the antiderivative of 3x squared. Now, but when you take it a little bit further, if f of x equaled, let's say, x to the third plus 7, right, then the derivative would also be 3x squared, right, because the 7 would drop off. Actually, big F of x could actually equal x to the third minus 22, and the derivative would still be 3x squared. So when we're taking antiderivatives, we kind of take that into account, that there could always be some constant in your original function that kind of falls off because the derivative is 0. So when so we're thinking more if it's a family of functions that could be any constant. So the way we note that is we would say f of x is actually x to the third plus c. So c just represents the fact that the derivative would be 3x squared and plus any constant that would fall off because of its derivative. So the way we symbolize this, the new notation we're going to use is the integration symbol, which is just kind of a stretched out s. So we'd say the integral of f of x dx, which just means that we are integrating using the variable x, equals capital F of x plus c. So when we're talking about this, so when we're referring to this notation, the stretched out s is called an integral sign. f of x itself, sorry, is the integrand. Dx represents the variable that we're integrating in reference to. So if we wanted to put the first example in proper notation, it would look like this. It would say, so the antiderivative of 3x squared dx equals x to the third plus c. So this is basically saying that 3x squared dx would be the derivative of x to the third plus c. Okay, so let's look at some examples of this. So just like in derivatives, where we learned different rules kind of every class to be able to approach different types of functions, we're going to do the same thing with integration. The good news, I guess, is that we won't learn as many rules for integration as we did for derivatives. So obviously we don't have as much time in the year, so we're just not going into it as deeply. But we're going to start with a couple anyway. So the first one, just like the first rule we learned in derivatives was power rule, the first rule we're going to learn in integration is power rule, because it's really the most useful. So, and it should be kind of intuitive for you guys after knowing how to take derivatives. So if we want to find the antiderivative of x to any exponent, x to the n, the rule is you take the exponent, you add 1, and divide by that new exponent, okay? And add a plus c. Another way to think about this is you take the exponent, add 1, and you multiply, if you think about it like that, or put it out front, the fraction of 1 over n plus 1 plus c. So when you think about it, that's really the opposite of taking a derivative, right? Because when we took a derivative, we subtracted 1 from the exponent and multiplied by this. So now we're adding 1 to the exponent and dividing by it. So we're really just undoing derivatives. Okay, so let's do some examples. So if we want to find the antiderivative of x to the 6th, we're going to add 1 to the exponent, which gives us 7, and then we're going to divide by 7. So the antiderivative of x to the 6th is actually 1 over 7 x to the 7th plus c. So if we were to take the derivative of this, we would get that. Okay, another way to write that, if you like, is x to the 7th over 7 plus c. It means the same thing. Okay, so let's try another one. So antiderivative of 2x dx. Again, this you have to picture this as having an exponent of 1. So we would add 1 and get 2 and divide by 2. So actually the antiderivative would be just x squared plus c. And again, one way to check this is to always just take the derivative of it. So if I took the derivative of x squared plus c, I would get 2x. Okay, let's try another one. So 3x to the 4th. Again, I add 1 to the exponent and divide by that new exponent. So I would get 3/5 x to the 5th plus c. And you do always need that plus c, because that represents the fact that you could have any constant after that function. And again, because its derivative goes away. Okay? So let's make it a little bit more fun with some fractions. So I'm going to rewrite this as x to the 1/2. So remember, with fractions, we add 1. So adding 1 would give us 3/2. And then we're dividing by that 3/2, which, if you recall, that's flippy-switchy stuff. So to multiply by the reciprocal, so this actually becomes 2/3 x to the 3/2 plus c. Okay, so if you need to stop the video and take a look at that for a second, go ahead. Just remember with fractions, adding 1, if we've got 1/2, adding 1 would be 2 over 2, would give us 3/2. When we divide by 3/2, to divide x divided by 3/2, we multiply by the reciprocal, and it flips it. Okay, you all have plenty of time to practice this also, remember that. All right, let's try another one. So when there's, just like in derivatives, when there's a polynomial, you can just go term by term and apply the power rule to each term. So for instance, here we're going to add 1, gives us 3, divided by 3. So our first term just becomes x to the third. And now on the 5, again, you have to think about that as it's really x to the 0. So constants now, when we're taking the antiderivative, constants become terms with an x, right? Because if this is really x to the 0, we add 1, we get x to the first. And then if we continue the rule, we divide by that new exponent, but it's actually just a 1, so it doesn't add anything. So the derivative, the antiderivative of this is x to the third plus 5x plus c. And again, you can always, it's a little confusing to go back and forth, but you can always take the derivative of it and see if you came up with your original function. Okay, let's try another one. So x plus 15 plus 2x squared. Again, first I'm going to do a rewrite. Move that over. So if I rewrite this, I'm going to say x plus 15 plus 2x to the negative 2. Okay, again, it's easier to work with negative exponents in this case. So now I start term by term. So I add 1. So this is like a 1. Add 1, I get 2. Divide by 2. So I get x squared over 2. This is x to the 0. I add 1. I get 1. Divide by 1. So that becomes 15x. Now negative 2, I add 1. I get negative 1. Divide by negative 1. So then I get negative 2 x to the negative 1. So if I rewrite that again, just to clean it up, I could say x squared over 2, or I could say 1/2 x squared, either one, plus 15x minus 2 over x plus c. Sorry. So take a look at that. Again, it's just applying the rules term by term. You may need to look at that again if you need to. But again, just remember, same thing as derivatives, you want to rewrite it with a negative exponent and then adding 1 to a negative exponent. Negative 2 plus 1 is negative 1. So just like you're always subtracting and taking derivatives, you're always adding in integration. Okay, let's try another one. So again, first I'm going to rewrite this as x to the 1/2 plus 4x plus, and if it helps you, go ahead and on your constants write it as 2x to the 0, if that helps you. So now we apply our rules. So I add 1, which gives me x to the 3/2, and I'm going to divide by 3/2. So when I divide by a fraction, again, that means I change flip, so I multiply by the reciprocal, so that becomes 2/3 x to the 3/2. For 4x, that's x to the 1. I add 1, I get 2. I divide by that 2, so I get plus 2x squared. X to the 0, I add 1, becomes 1. Divide by that 1, and I get plus x. Plus x. Plus. Okay, hang on, girls. I just messed that up. Sorry about that. Hopefully some of you caught that. Yeah, I was looking at my answer sheet while I was doing this, and I missed that. So when we're integrating 2x to the 0, I add 1, so I get 1, and then I divide by 1. So my new exponent is a 1, so I divide by 1. So this final term actually becomes 2x plus c. So sorry about that. Hopefully I didn't mess you guys up too much. Okay, so now let's continue to, so questions about any of that, I guess. Take a look. If you, again, rewind this and look at it again if that kind of went too fast for you. But keep in mind the main rule for integration is adding 1 to your exponent and then dividing by that new exponent. So anyway, you can take a look at that more if you need to. All right, so let's look at some special cases here. So again, just like in derivatives on our first day, we really, and currently in integration, we have no product rule or quotient rule. So when you're looking at a problem like this, it's foiling, it's best to FOIL it all together, then take the antiderivative of it term by term. So if we rewrite this, if we FOIL this together, we get what? X to the third minus 9x squared plus 6x minus 54 dx. So now we're going to take the antiderivative of this with reference to x. So we apply the rule to each one. So we add 1, we get 4, divide by 4. So our first term is x to the 4th over 4. Here we add 1, we get 3, we divide by 3, so we get negative 3 x to the third. Our exponent is 1, we add 1, we get 2, divide by 2, we get 3x squared. 54, you have to picture that as having x to the 0. We add 1, we get 1, divide by 1, so it becomes negative 54x plus c. Okay, let's try another one. So again, first I'm going to rewrite by foiling, so I get 3x squared plus 27x minus 5x minus 45. Combine like terms, I get 3x squared plus 22x minus 45 dx. So now I integrate. So I add 1, I get 3, divide by 3. So my first term becomes x to the third. So you could write that as 1/3 x to the third if you like. Oh, no, shoot, messed up again, sorry. So the 3 over 3 goes away, so it becomes 1x to the third. Messed it up again. And then 22x is x to the first, add 1, I get x to the second, divide by 2, so I get 11x squared. 45 has an x to the 0 with it, add 1, I get 1, divide by 1, I get negative 45x plus c. Okay, so hopefully it's starting to make a little sense to you. Okay, so again, if you're given a FOIL problem, you want to go ahead and multiply it out, FOIL it first, then take it term by term. Similarly, if we look at what we studied last time on our first day of power rule for derivatives, if you've got a polynomial that's being divided by a monomial, so a polynomial that's being divided by just one term, again, we don't have a quotient rule, so we need to simplify it term by term. So first, with this one, I'm going to do a rewrite, and I'm going to divide each term by, so I'm going to say x to the fourth divided by x, 6x to the third divided by x, 2x divided by x. So when I rewrite this, it becomes x to the third plus 6x squared plus 2 dx. And now I integrate it. I add 1, I get 4, divide by 4. So another way to write this, as I was trying to show you all before I made a mistake, you could write it as 1/4 x to the fourth. that is the same as x to the 4th over 4. Either way is fine. It's just a fraction. Next one, I add 1 to 2, I get 3. I divide by 3, so this simplifies to 2x to the 3rd. Plus 2 is really x to the 0. I add 1, divide by 1, so I get plus 2x and plus c. So always the plus c. I will take off points on a quiz or a test if you don't have the plus c. Okay, so I think last one. So let's take a look at last one. Okay, and again, this is a polynomial divided by one term. So I'm going to divide that x into everything. So remember that a lot of you guys miss points on these and derivatives just in the simplifying. So be careful to take note of this. So x to the 8th divided by x is x to the 7th minus 9x to the 5th divided by x is 9x to the 4th. 4x squared divided by x is plus 4x. Negative x divided by x is just negative 1. Here. Now, if I integrate, I add 1, get 8, divide by 8. So x to the 8th, so 1/8 x to the 8th. I add 1, I get 5, divide by 5, so minus 9/5 x to the 5th. X to the 1st, I add 1, I get 2, divide by 2, I get plus 2x squared. Negative 1 x to the 0, I add 1, I get 1, divide by 1, I get negative x plus c. So again, just like derivatives, once you get the hang of it, it's kind of fun, at least in the math teacher world. So anyway, I've given you pretty much an example of everything you'll need for the assignment. So I've got, your assignment today is just a worksheet that has, I think close to 20 of them on it that the sub will give out. Anyway, it's a pink worksheet. If you have questions about it, you can talk to each other about it, or even better, look back in these notes, because like I said, I have really covered every type of problem you'll have. But just practice with it, and again, it becomes pretty automatic. My advice, though, is just don't think about derivatives too much, because it kind of messes you up when you think about derivatives and integration together. It's kind of confusing. So anyway, do your best, practice with the worksheet, and we will go over it on Wednesday. All right, thanks. See you soon.